Okay, good day guys. Right now we're gonna get into the new topic that is non-ferrous metals. And non-ferrous metals is a metal including alloys that does not contain iron in appreciable amounts. Generally more costly than ferrous metal. Non-ferrous metals are used because of their stable properties such as low weight like an aluminium, higher conductivity like a copper, non-magneticity property or resistance to corrosion like a zinc. Some non-ferrous metals are also used in the iron steel industry. For example, both is used as slugs for blast furnaces, while others such as wolframite, pyrolusite, and chromite are used in making ferrous alloys. Important non-ferrous metals including aluminium, copper, lead, nickel, tin, titanium, and zinc, and alloys such as brass, precious metals such as gold, silver, and platinum, and exotic or rare metals such as cobalt, mercury, tungsten, beryllium, bismuth, cerium, cadmium, niobium, indium, gallium, germanium, lithium, selenium, tantalium, tellurium, vanadium, and zirconium are also non-ferrous. They are usually obtained through minerals such as sulfides, carbonate, and silicates. Non-ferrous metals are usually refined through electrolysis. For example, of the ferrous metal we deal with fissile scarp metal, the Mosellian side scarp metal, metal aficots from manufacturing industry. Non-ferrous metals do not contain iron, are not magnetic, and are usually more resistant to corrosion than ferrous metals. Some examples of non-ferrous metals we deal are aluminium alloys, copper, brass, lead, zinc, stainless steel, and electrical cable. Aluminium is widely used often in alloy forms. An example is duralium and alloy used in aircraft manufacturing, which also contain copper 40.4% and magnesium 1.5%. Aluminium can also be alloyed with titanium to produce very strong, lightweight metals. Copper is an excellent electrical conductor, which makes it ideal for use in electrical wires. Good ductility also makes it suitable for pipes. Copper is widely used in alloys, notably brass, in brackets copper and zinc, and bronze in brackets copper and tin, and sometimes lead. And silver. Silver is a precious metal, a reference to its high cost. It is better electrical conductor than any other materials, so it is often used for electronic connection. Another precious metal is gold. It's also an excellent conductor and is highly corrosion resistant. So that far, are you understand, guys? Okay. Non-ferrous metals were the first metal used by human metallurgy. Gold, silver, and copper existed in their native crystalline yet metallic form. These metals, though rare, could be found in quantities sufficient to attract the attention of humans, less susceptible to oxygen than most other metals. They can be found even in the weather outcroppings. Copper was the first metal to be forged. It was soft enough to be fashioned into ferrous objects by cold forging and could be melted in a crucible. Gold, silver, and copper replace some of the function of the other resource, such as wood and stone. Owing to their ability to be shaped into various forms for different uses, due to their rarity, these gold, silver, and copper artifacts were treated as luxury items and handled with great care. The use of copper also heralded the transition from the stone. Non-ferrous metal is used in residential commercial industry. Material selection for a mechanical or structural application requires some important consideration, including how easily the material can be shaped into the finishing part and how its property can be either intentionally or inadvertently altered in the process, depending on the end use. Metals can be simply cast into the finishing part or cast into intermediate form, such as an ingot, in the work or wrought by rolling, forging, extruding, or other deformation process. Although the same operation are used with ferrous as well as non-ferrous metal and alloys, the reaction of non-ferrous metal to this forming process is often more severe. Consequently, properties may differ considerably between the cast and wrought forms of the same metals alloy. And our last for this topic is plating with non-ferrous metals. Non-ferrous metal can be used to protect steel from corrosion by plating it, that is, covering it with a thin layer of metal. An example of glazing, like in brackets zinc plating. Steel can be hot dip glazing by placing in a molten in brackets liquid zinc. It can also be electrogalvanized, which is a type of electroplating. With this technique, the steel component is placed in a liquid in bracket, often an acid, called electrolyte, and connected to the negative terminal of an electrical supply to become the cathode, in brackets the negative side. A piece of zinc is also placed in electrolyte and is connected to the positive terminal of the supply. This then becomes the anode, or in brackets the positive side. An electrical current then flows between the pieces of the metal through the electrolyte. This causes a chemical reaction which deposits zinc on the cathode, plating the component. A related process called anodizing is used to protect aluminum. The component to be anodized is connected to the positive terminal in brackets to become the anodide, and place it in the electrolyte with a cathode. As electric flows, aluminum oxide is deposited on the anode. This is harder than aluminum metal. It provides protection. So, this is the end of our topic. Thank you for listening.